Okay, this lesson is on trinomials, factoring trinomials when a is greater than 1. Perfect square trinomials, factoring squares. Okay, I can statement. I can do these things, be able to factor perfect square quadratics, be able to factor difference of squares, be able to factor quadratics where a is greater than 1. Okay, talk to your teacher if she or he wants you to be able to do this puzzle. Talk to them. If not, moving on. Okay, here we've got some perfect square trinomials. Notice, remember, perfect squares mean they are numbers such as 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are the perfect squares, 1 through 144. Okay, so we're going to be looking for patterns that we can do some shortcuts if so. If you don't find a pattern, then you can use the crisscross method or factor, which is our X method, where this is A times C and this is B. And then you're going to put two factors out here, factor 1 out here and factor number 2 out here, okay? All right, so here's some examples. The two things I want you to concentrate on are step 1 and step 2. Step 1 says A has to be positive, so if A is less than 0, you need to factor out a -1. You also need to factor any GCF if 1 exists, okay? So those are the main two I'd like for you to start with. So let's look at problem A. Okay, let's identify A, B, and C. So A is -1, B is 8, and C is -16. So our A is -1. It's less than 0. So we've got to factor a negative out before we can even begin to either do the X method or the perfect square trinomials. Okay, so let's factor out a -1. So we're going to get -1 out here, leaving me with x squared. Okay, positive divided by negative is a -8x, and negative divided by negative is a positive. Notice that if we factor out a -1, the signs will change on the quadratic, okay? Now, our A now, we're going to concentrate on this grouping right now. Our A now is 1, our B is -8, and our C is 16. The numbers change just a little bit due to factoring out the -1. Okay, if A is a perfect square and C is a perfect square, there's a quicker way than using the crisscross or the X version of factoring. You could try it and check it. So let's put our -1 here and let's factor. Let's put two binomials here. What you can try and do, if A and C are perfect squares, okay, you can take the square root and we can try to see if those numbers will add up to be the middle term. So square root of 1 is 1 and 1. Split your x's. Square root of 16 is 4 and 4. Okay, now if it's negative here on the inside, it will be negative, both negative here. But you have to check it to see if that truly works. 1 times -4, 1x times -4 is -4x. -4 times 1x, multiply the insides, is -4x. Do these add up to be -8x, which is in the center? Yes, they do. So this is factored correctly, all right? Now I'm going to erase this right here so I've got some room to write. And we're going to rewrite this as -1 times x minus 4. We have two of them that are the same, so I'm going to put a square there. There is your answer right there. Sometimes factoring perfect squares is a little quicker than using the X method, but if you want to use the X method, that's great. Okay, let's try B. Okay, our A is 1, our B is -13, and our C is 36. So our A is positive. And you need to check for GCF. Is there a number that can divide out of 1, 13, and 36? No. So we're ready to go. Okay, if A is 1, you're just ready. Okay, let's make our two binomials. Now, A is a perfect square, C is a perfect square, 36. They are part of our perfect squares over here. Okay, so what we're going to do is we're going to split out our x's, x and x. Square root of 1 is 1. Square root of 36 is 6. Okay, and because it's negative here in the middle, let's try negative. Now, you need to test this. Multiply the outside terms together. We get negative 6x. Multiply the inside numbers. Negative 6 times 1x is negative 6x. If I add these up, I get negative 12x. Is that the middle term? It is not. So we cannot factor using perfect squares on this one. And that's just one of the challenges of factoring we need to at least check. So 6 and 6 is not going to work, but there are two other factors that will give you 13, negative 9 and negative 4. And those will check. Negative 4x, multiply the insides, negative 9x, and these indeed add up to negative 13x. So that works. So your final answer is x minus 9 times x minus 4. It's good if we can use the perfect squares, but if we can't, we just go ahead and pick two other. You can use the x method. I just kind of knew that 9 and 4 would work, give me 13, so I used those numbers. All right, let's look at C. Is there anything I can factor out of all three terms? 9, 24, and 16, no. So let's see if we can do this the quick way. 9 is a perfect square, 16 is a perfect square, so let's take the square root of these terms. Square root of 9 is 3 and 3, x and x. 16 is 4 and 4, and because it's positive on the inside, these are both going to be positive. But we need to check to make sure that that works. So multiply the outsides, 4 times 3x is 12x. Multiply the insides, 4 times 3x is 12x, and these indeed make 24x, which is my middle term. So that's really great. So that worked out okay on that one. Now, one thing you need to do is write 3x plus 4. We have two of them that are identical, and so that's how you write it. Okay? All right, let's do D. D's A term is negative, B is 10, and C is negative 8. Okay, we've got a problem with this negative 2. So let's look. Could I factor something out of 2, 10, and 8? Yes, I can factor out of 2. The first term is negative, so I need to divide that out. Can I get an x out of all three terms? No. So it leaves me with x squared. 10 divided by 2 is 5. 8 divided by 2 is 4. Now, I left the signs blank for this, okay? If you're dividing out a negative 2 out front here, the signs are going to change. So instead of a negative, this is now a positive. Instead of a positive, this is now a negative. Instead of a negative, this is now a positive. Okay, now you can try and factor. This 1 is a perfect square and 4 is a perfect square. But think about the square root of 4. Square root of 4 is 2 and 2. Is 2 and 2 going to add up to be 5? No. So unfortunately, we are not going to be able to take the square root because 2 and 2 gives us 4. So you could use the crisscross method or the x method, but just to help you out here, split your x's, x and x. Is there factors of 4, 2 and 2 that would give me 5? Okay, 4 and 1, right? So it'd be negative 4 and a negative 1 because this is going to give you negative 1x, this is going to give you negative 4x, and these add up to be what? Negative 5, okay? So your final answer here, I'm running out of room, is x minus 4 and x minus 1. That is your final answer. All right, okay, let's look at E. E. Okay, is there a number I can divide out of all three? No. But A is a perfect square, C is a perfect square. So let's try to use those if we can so that we can go a little quicker. Square root of 4 is 2, so we'll put 2 2's. Square root of x squared is x and x. Square root of 25 is 5. Okay, because it's a positive in the middle, it'll be a plus and a plus. Okay, let's see if that's true. Multiply the outsides together. 5 times 2x is 5x. 5 times, or no, excuse me, that is not right. 2 times 5 is 10x. 5 times 2 is 10x. Does that give us the 20x we need in the middle? Yes, it does. So, final answer, 2x plus 5, oh my goodness, there we go, raised to the second power. There is your answer. All right, okay, last problem, F. What can you divide out of 8, 24, and 18? Probably a 2. And A is positive, that's good. So we're going to divide all these by 2 to get our new smaller quadratic. So 4x squared minus 12x plus 9. Okay? All right, 4 and 9, this A and this C are perfect squares. So you could try taking the square root of those. Square root of 4 is 2 and a 2, x and x. Square root of 9 is 3. We need a negative in the middle, so it's got to be minus minus. So let's check to see if that's going to work. 2 times negative 3 is negative 6x. Negative 3 times 2 is negative 6x. Do those both add up to be negative 12x? Yes, correct. So our final answer is 2 times 2x minus 3 to the square. This will be your answer. Okay? All right. Okay, factor the polynomial completely. Once again, we've now learned some rules that when A is a perfect square and C is a perfect square, we could try to do it a little quicker rather than use the X method. But if you want to use the X method, that's okay. Okay, remember that this is A times C, this is B. Let's use the X method first, then we'll try to use the perfect squares next. Okay, so A is 1 and our C is 9. So what is 1 times 9, guys? 9. Okay, middle term, negative 6. That's the term that goes there. Okay, factors of 9 are 1 times 9 and 3 times 3. Which ones would add or subtract to give us 6? The 3 and 3. But we need negative 6 here, so we have to put negative negative. If we do negative 3 times negative 3, it gives us positive 9. So we can write it like this, x minus 3 and x minus 3. Or y equals x minus 3 squared. Okay, now guys, what we can do is, because A and C were perfect squares, we can just do it like this. Square root of 1 is 1. Square root of x squared is x and x. Square root of 9 is 3. Because it's a minus in the middle, these will both be minus. Now you can check it. 1x times negative 3 is negative 3x. Negative 3 times 1 is negative 3x. And these add up to be negative 6x. So it is going to check that that's the middle term. Final answer, x minus 3 to the second power. Okay? So can I do it either way? Yes, you can try and do, I call it kind of a shortcut way, knowing the squares. If not, you can use the x. Okay, we've already listed the squares 1 through 12 right at the beginning. Okay, now this is simplified. There is nothing that separates these two parentheses, which means if we're going to simplify, we're going to multiply. We learned how to do this when we learned how to multiply polynomials, so we should know how to do this. X times x. Remember, when you multiply same variables, you add the exponents, right? 7 times, or x times negative 7. I'm going to write it out the longhand way for teaching purposes. 7 times x, and then 7 times negative 7, right? Okay, so x times x, remember, add the exponents, x squared. X times negative 7, negative 7x. 7 times x, 7x. 7 times negative 7, negative 49. Combine like terms. These are going to be my like terms. They add to 0, so I get x squared minus 49. Notice that A is a perfect square and C is a perfect square. Notice what happened back up here. The square root of x squared was x and x. The square root of 49 is 7. It's 7. But notice the signs, plus and a minus. Well, that comes because our middle term here is 0x. So one has to be positive, one has to be negative. So let's look at it over here. Okay, well, they want you to, it says, look at A and C. What kind of numbers are they? Well, A is a 1, so that's a perfect square. 49 is a perfect square, right? They're perfect squares. They're one of the numbers, 1 through 144, that we wrote down. They're perfect squares. Okay? All right, so we're going to factor some of those right here. But again, I want you to concentrate on step 1 and step 2. All right. Okay, step 1, is our A value positive? No, it is not. Our A here is -1. Our C here is 25. Okay, but we need to factor out the -1 to start out with. So we've got -1 times, so negative x squared, positive divided by negative is -25. Okay, now, just so we know, x squared, there is no middle term. It is 0x minus 25. That's good. When the middle term is 0, it means when you go to factor this, you're going to have a plus and a minus. Okay, the square root of x squared is x and x. And if you want to put ones in front of those, go right ahead. Square root of 25 is 5 and 5. And you just factored it using perfect squares. Okay, let's do B. Okay, does it have a GCF? Yes, it does. It has a 9 as the GCF, so x squared minus 9. Divide both terms by a 9. Okay, now this right here is x squared plus 0, x minus 9. Okay, once again, if your middle term is 0 and your A and C are perfect squares, take the square roots. So we're going to have 1x and 1x. Square root of 9 is 3 and 3. And if it is 0 in the middle, guys, positive, negative. You just factored that. Group of numbers. Okay, here we go. Let's look at C. My A is positive, but can I factor anything out? Yes, I can, a 4x. So let's do that. X squared minus 25. Okay, divide this by 4x and divide this by 4x. Okay, all right, so now I've got 4x, make 2 parentheses. My A is 1. Take the square root of 1, so it's 1x and 1x. Square root of 25 is 5 and 5. Because there is no middle term, plus and a minus. Doesn't look very good there, so let me put a minus there. All right. Okay, very good. Okay, let's look at D. D, is there anything I can factor out? No. Is A positive? Yes. But my A is a perfect square, and my C is a perfect square. Okay, square root of 49 is 7 and 7. Split your x's. Square root of 1 is 1 and 1. There is no middle term, so we're going to have a plus and a minus. Okay, E, what can I factor out of both terms? A 3. That's going to give you 25x squared minus 1. Notice that A is a perfect square, C is a perfect square. So you can take the square root of these. So we're going to have 3 times. Square root of 25 is 5. X and x. Square root of 1 is 1. And a plus and a minus. Okay, last one, F. Here we go. What can we factor out? Our A is negative, so we got to factor it out. Can I take out a 2? Yes, you could, out of both of these terms. So we got -2 times x squared plus 36. All right, now, notice when we got through all these problems, this was a minus. 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 But this time, what do I have here? A plus. If it is a plus sign, you cannot factor any more. It is what it is. You cannot factor this problem any longer. It must be a minus sign in order to do the difference of 2 squares. Okay? All right. Next problem. All right. Because our A is a 1 perfect square, our C is a perfect square, and it is a minus sign, guys. Hallelujah. We can do x, and 6, and because it's a minus, it will be the difference of two squares. It's a plus minus, okay? You're okay if it is a minus, but as soon as it goes to a plus, you won't be able to factor it. All right, here we go. Let's try it again. More practice. Square root of 9. 9 and 25 are perfect squares, so we'll get 3x and 3x. Square root of 25 is 5 and 5. Because it is a minus sign and there's no middle term, plus and minus, difference of two squares. Okay? All right, next. Maybe. All right. Okay, now, if you don't want to use those, okay, always use the X method. That's another way you can do it. Okay, now we're going to get some problems where A is bigger than 1. Here's some rules for you. First step, number 1. Make sure that A is positive, and if A is not equal to 1, see if you can get a GCF out. Find the factors, use them to rewrite the problem. Okay, notice that this time we're going to have an A in front because we may have to factor out a GCF. Okay? All right, this kind of walks you through the little steps here. So let's start here with this problem. First thing you want to do is see if A is positive. It is. Okay? This is your A, this is your B, this is your C. But before I start, is there a number that can factor out a 4, 14, and 12? Yes, it is. It's a 2. So let's everybody divide by 2. All right, so our new problem is going to look like this. We're going to divide out a 2. That leaves us with 2x squared minus 7x plus 6. All right, now we're going to leave this 2 outside for a while and not work with it. This is the part we're going to work with, okay? All right, now you can do it one of two ways. You can do the box method here, or let's see, we can do the X method, I believe. All right. Okay, let's try this. Let's try the box method, okay? Okay, I'm going to teach you how to do the box method. Okay, this first term right here, 2x squared, the ax squared term is going to go up here. So we're going to put 2x squared. The constant, this is the constant, or the C, goes right here. It's a positive 6. Now, to get these two boxes right here, what we have to do is we have to draw an X. And we have to do A times C. What's 2 times 6? 12. And then we're going to put the middle, the B term right there. Okay, we're going to write the factors of 12. 12 is 1 times 12, 2 times 6, 4 times 3. And we need 7. It's probably going to be 4 and 3, 4 and 3, and they're both going to have to be negative because they have to add up to be negative 7, and then they have to multiply to get you to 12. These two factors right here are what go in the box. It does not matter which order you put them in. Okay, just get them in those two boxes. All right, now, because I'm going to run out of space here, I want to show you something here. Okay, what we're going to do is we're going to factor out the GCF by row and by column. So let's do the rows first. So I'm looking at this first row right here. This is your row. This is row 1. Okay, right here is going to be your row. Okay, this is row 1. This is going to be row 2. This is going to be column 1 and column 2. Okay, all right. Okay, let's go for row 1. What can you factor out of 2x squared and negative 4x? Okay, a 2 with an x. They both have an x. Now, if you're not sure what I'm talking about, this is 2 times 1 with an x. 4 could be 1 times 4 or 2 times 2 with an x. What do they share in common? A 2, and they share a what? X. That's how we got 2x out here. All right. Okay, now, let's do row 2. What can you factor out of 3 and 6? Is 3 a factor of 6? The answer is yes. Okay, now, if this 3 is by a box. Right next to a box with a negative sign, you've got to factor out the negative. Or in other words, if you read it from the left to the right, okay, this is your first term, negative 3x. You factor out this negative and get it to the outside, okay? All right. Okay, now, the next thing we're going to do is we're going to do column 1. Let me put this 3 times 1 and an x here. Let's do 1 times 6 and 3 times 2. All right, now, let's think about these. I'm going to rewrite these right here. This was 2x and x. Okay, I just want to erase these that we have circled so it doesn't get confusing. All right, now we're going to do column 1. So let's look right here at column 1. All right, we're going to look at 2x squared and 3x. What do they have in common? Well, the only thing they have in common is a 1 and an x. So we'll just put 1x right there. Okay, column 2. What do I have in common? Well, they have a 2, and that's it. However, this top term has a negative, so it'll be negative 2. All right, now, how you're going to write your answer is this. You're going to take your side terms right here. 2, negative 3. Go 2x minus 3. You're going to take your top terms, x minus 2. Now, what was the number we factored out at the very beginning, right here, that we had to set aside for a minute? The 2. We have to put it back into the answer. Okay? So there's your answer. And you guys just factored a trinomial where a is greater than 1. Okay? All right, let's do this again. All right, let's check for GCF. Is there any number that can divide out of 5, 31, and 6? The answer is no. We are going to use the box method again. So draw a 2 by 2. Okay, since we have no GCF, 5x squared will go in the top left hand. The constant 6 will go here in the bottom. Now, to get these two boxes here and here, we have to use the x method. So go ahead and draw your x on your paper here. Okay, we're going to do a times c. 5 times 6 is 30. Put your b term right here at 31. Okay, write your factors of, I'm going to do them over here this time, is 30. You've got 1 and 30. You've got 2 and 15, you have 3 and 10, and we already did this probably earlier, 6 and 5. Okay, which ones would add up to give me 31? I'm going to choose 1 and 30. 1 and a 30. Okay, positive, positive. They will add up to be 31 and multiply together to give you 30. So take this 1 and put 1x in this box. You're using these two terms. Take your 30, put it right there. Okay? All right, once again, we're going to do row 1, row 2. So in row 1, right here, what is a number that can divide out, or a variable that can divide out of both terms? Let's start with the numbers. 5 and 1 can divide out of 1. X squared and x, I can use an x. Okay, let's do row 2. Okay, what can I divide out of both 30 and 6? If 6 divides into 30, 6 is your GCF. Do they both have variables? No. All right, let's do column 1. Okay, starting with 5x squared and 30x. What can I divide out of both 5 and 30? A 5, and I can get an x out of both of them. Okay, column 2. What can I divide out of both of those terms? Just a 1. Okay, final answer will be y equals. Okay, put these terms in your first set of parentheses. X plus 6. Okay, put these terms in your set of parentheses. 5x plus 1. And that, guys, you just factored a trinomial using the box method. Okay? Okay, let's do this one by grouping. let me show you grouping. Now, what do you have to choose? Box method or grouping? I don't care. I don't care what you use. You can choose either one, but you're going to know two methods. This is grouping. Okay, first thing, check for a GCF and make sure your A is positive. Do I have a GCF? No. Is my A positive? Yes. All right, so here's what we're going to do. We're going to write two parentheses. And we're going to put our ax squared term right here, 2x squared. It'll be our first term in the first binomial. The 20 is going to be our last term in this binomial. Okay, and it's a positive. All right? Okay, now we've got to get these two terms right here. And how are we going to get them? We're going to use our x methods. Everybody draw an x. Okay, do a times c, 40. Put your negative 13 right here for b. Okay, these two terms right here on this side will fill in the blanks over here in the binomials. All right, okay, let's do 40. Okay, we've got 1 times 40. We have 2 times 20. We have 4 times 10. And we have 5 times 8. I'm going to stop because it'll be 8 and 5. Or 5 and 8. Okay, both signs have to be negative to add to negative 13 and to multiply to 40. So we're going to put negative 8x there, and we're going to put negative 5x here. Now, like the box method, we're going to look for a GCF. So in this first group right here, in this first group of binomials, what can I divide out of 2x and 8x? A 2x. So that gives us x minus 4. Okay, when you divide out a 2x. Okay, second group, what can I divide out of these two? It'll be, because my first term is negative, it's going to be a negative 5. Negative 5 can divide out of here and out of here. So you're going to be left with x minus 4. Because a positive divided by negative is a negative, okay? All right, guys. All right, let me make this a little bit better. Now, when you do grouping, you should end up with, notice right here, this is a term and this is a term. You should end up with a factor that is the same. Notice it's these two right here. So put x minus 4 in a group and factor it out. So what does that leave you with? A 2x and a negative 5. So put 2x minus 5. And you just factored that trinomial by grouping. Now, I don't know if you guys like grouping any better than you like box method, but you choose whatever way you like to do it. Okay, let's do this one by grouping. Okay, look for the GCF. In this case, there is a GCF. It is 3. So we're going to divide everything through by a 3. Okay, so now it's going to be 5x squared minus 9x minus 2. Okay, all right, now we're going to leave the 3 out front. We're just going to leave it alone for a minute. And we're going to deal with this part right here. So let's make 2 parentheses. And we're going to put, this is now our new A, our new B, and our new C. So 5x squared is going to go here, and negative 2 is going to go here. Now, how are we going to get those other two numbers? We're going to do A times C. So what's 5 times negative 2? Negative 10. And we'll put negative 9 here. Okay? Factors of 10 are 1 and 10 and 2 and 5. Which ones could I use to give me 9? Probably right here. And it's a negative 9. So that means the 10's got to be negative. The 1's going to be positive. So positive 1, negative 10. Those add to give you negative on 9 and multiply to give you negative 10. So these two are going to be my terms, 1x and minus 10x. Okay? All right, now looking at this term, what can I factor out of both of here? Those terms and x. So I left with 5x plus 1. What can I factor out of both negative 10x and negative 2? A negative 2. It has to be negative because my first term is negative. So that leaves me with 5x plus 1. When you divide it by a negative, that's what you get. Okay? All right, now, what did both of these terms share? They share 5x plus 1. Correct. Now, if I factor that out, what is left to put in my next group? X minus 2. But you can't forget about the number you factored out from the very, very beginning. What was it? A 3. There's your answer. Okay? So that is factor by grouping. Okay, now, when you get to here, guys, we have an issue here. 10x squared minus 15x plus 0. And I want you to know that there's a 0 in the C spot because 0 is where this quadratic will cross the y-axis at. However, if you have a 0 here in the C spot, you cannot use the x method. That is not available. You can't even do perfect squares or anything because think about it. If you do 10 times 0, you're going to get a 0 here, and your middle term is negative 15. Are you going to be able to find factors of 0 that add up to be negative 15? Of course not. So this does not work. So look for a GCF. That's all you can do. What can you divide out of? 10x squared and 15x. Well, you can divide a 5 and an x out. So if I divide a 5x out of here and divide a 5x out of here, that'll give you 2x minus 3. And that is your answer. Okay? All right. Okay. So please finish up lesson 2 class notes. There is a Delta Math assignment. Fill out your exit ticket number 2. Thank you.